Okay, let us take an example. Okay, this is R, L, C, and let's say this is the input, this voltage, and I am taking the output as the current flowing through this capacitor, this series connection. Output is current and input is voltage. Now, can you tell me what is the differential equation governing this circuit? If you apply KVL, what is this voltage? We can write XT as what? Sum of the voltage drop across the resistor plus voltage across the capacitor plus voltage across the inductor, isn't it? So what is the voltage across the resistor?
YTR.
R into YT plus then voltage across the inductor?
L D by
L d by t by dt plus voltage across the capacitor is 1 upon.
integral.
Okay. We can convert this, here there is integral differential derivative, so we can convert it into a differential equation by differentiating both sides with respect to t. If you differentiate both sides with respect to t, you will get this relation. This is I'm taking this term in the left hand side because that is the standard notation. This is r into dy t by sorry, the first term will be okay. Let us if you rearrange the terms, you will get this. Just a minute. Okay. So we can write it as I'm taking from here. This is 1 by r, 1 by c, yt plus L into, sorry, this is the first term, r into dy t by dt plus L into d square yt by dt. This is the differential equation, isn't it? This is the differential equation. This is called a linear constant coefficient differential equation. So the general form of a linear constant coefficient differential equation is, it is like this: a0, sorry, there is a standard notation. Yeah, a0 yt plus a1 y dash t plus like this, and an, that is the nth derivative. Okay, let us write it in terms of d by dt yt, and this is the nth derivative. Okay, that is equal to b0 xt plus b1 d by dt xt plus okay, this is a this is the general form of linear constant coefficient differential equation. We can simplify this notation. We can write it as summation k from 0 to 0 to here it is n a k okay. This is the general form of linear constant coefficient differential equation. What is the what is on this, what is the summation on the left hand side? Is it linear combination of derivatives of the output? xt is the input, yt is the output. So the summation on the left hand side is the linear combination of what? Linear combination of derivatives of the output. And on the right hand side, we have linear combination of the derivatives of the input signal. Okay, so this is the general form of linear constant coefficient differential equation. And for discrete time systems, that is also denoted by LC, linear constant coefficient. It is here it is differential equation, but for discrete time system, it is difference equation. The general form of linear constant coefficient difference equation is in the left hand side, we have linear combination of delayed versions of the input signal. So the corresponding operation here is difference. So here we consider delayed version of the input output signal, and right hand side we have linear combination of delayed versions of the the input signal. This is called linear constant coefficient difference equation. Okay, so there are many practically means important systems can be characterized by using this difference equation and differential equation. We'll discuss few examples later on when we discuss the Laplace transform and the corresponding transform in the case of difference. The discrete time system is the Z transform. How is we are given a linear time invariant system that is described by this difference equation. And if you are given that the system is causal, it is a causal system. Can we find the impulse response of the system? We are given a system described by this difference equation, linear constant coefficient difference equation. It is a causal system. That information is also given. Can we find the impulse response of the system? How do we find the impulse response of the system? If you give xn as the xn is equal to delta n, what is the output? That is denoted by hn, isn't it? Now, if you substitute this xn is equal to delta n in this difference equation, what will be this? If you are putting xn as delta n, what is yn? Is it hn? Is it the output corresponding to the impulse response?
Yes, sir.
So can we write hn minus 1 is delta n?
Yes, sir.
Isn't it? Now, given that the system is causal, what is h0? If you are given that the impulse response is the system is a causal system, we know that hn is 0 for n less than 0. That is the condition for causality. We need to find the values of hn for n greater than or equal to 0, isn't it? Because the system is causal. Now, what is h0 here?
Delta n.
It is not delta
Delta
n. The
zero.
value of that
Delta
function
zero,
at
yeah.
0. Delta 0 is 1, isn't it? Since it is causal, h minus 1 is 0. Now, what about h1?
1.
1. h2?
All 1.
All 1. So, we can say that hn is un, isn't it? Is it? So we can find that impulse response of the system recursively.